Well, yes, first of all, I think we are missing one part there with the title, because we are saying resilience through implementation of DVT, and actually, as I'm representing Nectar Network, is resilience through implementation of DVT, not just in staking, but also in re-staking. It's funny that I am speaking after Lido. I mean, for two things. First, I'm not the most technical guy in the room, so Alex knows way better than myself all the technical details. And the second fun thing, or fun fact, is that one of the key drivers that made us build all of this, it was actually to avoid centralization within Ethereum. There are certain ways to prevent centralization, and the way that we decided to fight against centralization was through a technical innovation. That technical innovation is DVT, and is what I'm explaining here. It's the core of everything that we are building, and we are developing our own DVT technology. And why is that important? With a centralized Ethereum network, actually, it's not even a network at all. It's just a bunch of players controlling a distributed ledger, and they can be able to modify whatever they want. But the biggest issue that we are facing right now, because I think everybody has spoken about why centralization is bad for Ethereum, I think one of the biggest risks that we are facing, and is what we are trying to fight against from Nectar Network, is decentralization within re-staking. Everybody was actually fighting against Lido, decentralization powers. We were asking about how Lido is decentralizing its base of operators and validators, but nobody was taking care about one major and obvious centralization force, which is eigenlayer. What is re-staking? To understand what is the danger of one single agent controlling the whole re-staking market, we have to understand a little bit about how re-staking works. Re-staking, at the end of the day, is no more than using Ethereum's collateral to secure other things. So the concept is relatively easy. And what, in my mind, is not well explained most of the times, is that you are not slashing a validator in Ethereum. You can force a validator in Ethereum. You will be able to force a validator in Ethereum to exit once AP 702 gets implemented, and with our solution way sooner than that. But the slashing doesn't happen natively in Ethereum. That is not going to happen. So first, you are forcing a validator to exit in Ethereum, and you are penalizing that validator. You are slashing that validator in the AVS, in wherever that validation is rendering the services. Is that bad? Is that inherently bad? Not really. One of the things, so the good things that the re-staking brings to the table, and it's something that we have discovered, again, we migrated from LST or pure LST to re-staking. One of the things that we discovered when analyzing re-staking is that economically, it makes the total sense. If I want to bootstrap a network, why should I start from zero and get something brand new, try to bring along operators, get my whole economic system when I have all the people that is working already in Ethereum and they are doing an excellent job? Let's try to use that. I mean, let's try to make Ethereum the center of this beautiful universe that we are building in here. And one of the best things that you can do actually by doing this is that you know that all those node operators that you are bringing to your system is people who is actually performing a good job in Ethereum. You get that trust of that people that is engaged in something way bigger than whatever you're building. And the last point that is extremely important is the revenue, the pure economic system. One of the things that everybody's complaining about is, okay, being a sole operator in Ethereum doesn't give me that much benefit. At the end of the day, the APR nowadays will be on the range of 4% or something like that. But if we have another sources of income to all those people that are helping to secure the network, you are making economic system sustainable. one of the good things that we get also in the REST-Aiken ecosystem, or when you are implementing REST-Aiken, is that you can do everything way more modular. You can craft anything at your demand. Because you are creating something new, at the end of the day, again, when everybody is asking, what is REST-Aiken at the end? OK, it's just using Ethereum security to secure something else. That is the simplest answer of all, even for me that I'm not technical at all. But one of the things that we have to take into consideration is that there are dangers out there. And the biggest danger, and is what Vitalik was saying in the phrase that I was mentioning before, or that I was showing before, is that you cannot take all the social consensus from Ethereum and endanger the Ethereum network to your private use. One of the things that we are seeing, I just mention it because it's obviously the obvious case and the leader in the market. One of the issues that we are having with Eigenlayer, even now that they have launched the Eigen token, is that I think for everybody that has been here for a while, it brings a lot of vibes like FTX, all the Luna thing. They are going to use Eigen as a way to secure AVSs. So, OK, you are using your own token to secure a network, and you are trying to mix up Ethereum, all of this, and you are implementing a fork of your own token that is going to be decided by the community. How does it going to be? I mean, how does it going to affect the Ethereum layer? How does it work? How does it fit in? In general, we are avoiding that principle of, OK, let's use our own token as collateral, because truth to be told, we have previous experience with that, and it didn't work that well. So coming back to DVT, what DVT does and how it's being used here. Again, I mean, doing this talk after CSM is kind of weird. I mean, I'm not going to explain once again about DVT because he most probably has explained already what are this event validation technology. But just to simplify, at the end of the day, what you want when you are implementing a new network is that network needs to be live. I mean, you need liveness. That is obviously clear. But the most relevant thing of all is security. You need that security in order to avoid the slashing. So you need something resilient. And that is what DVT brings to the table. How does it work? Again, it's relatively easy to understand. At the end of the day, what you have is you are getting something that needs to be signed, and you are splitting that between different nodes, and they have to sign, you have to recompose that key share, so everything gets signed. To understand how it works, I mean, and also the security and how this affects the security of the network, even in CSM, in Lido, in every application, OVL, SSB, you have two variables. One is, OK, you have to make subsets, and you can use any number that you want to use between the nodes, 5, 7, 16, 22 if you want to. The only thing that is going to top you is the latency. And you have to decide what is the number of those nodes that need to be what performance, using the analogy that Alex was using before, and how many of them can fail. What is the thing? There is something that sells a lot, which is, OK, I'm going to make sets with a ton of nodes because I'm reducing the collateral that needs to be deposited by each single node. That is the kind of the most commercial approach, but generally, from a technical point of view, it's not the best approach. And again, you have to find an equilibrium of the security over what is commercially attractive or the way that you democratize. So you have to find always a way in the middle to handle all that diversity in both performance of operators, geographical distance, and position. What are the benefits? I mentioned some of them, and also Alex was mentioning some of them. What we are trying to do here is, I always like to say, create a layer 2 of validation over the Ethereum itself. So we are lowering the collateral per operator, so we are making everything more accessible to everyone to become an operator. We always say that our dream is that anybody without knowledge of technical knowledge or without coding experience will be able just following clicks to become an operator or a validator in Ethereum through our DVT network or our DVT solution. That is on the validation side. On the risk-taking side, obviously, is that but increase in the source of revenue and the services that a node operator can provide. By doing that, we are increasing the decentralization of the network because we are enabling more participants. We truly believe that Ethereum should be open for everyone and not just to professional node operators. This has been kind of our motto, and we said that it doesn't really matter if you are a really bad performer. I mean, obviously, the network will kick you out if you are a really bad performer, but it has to be resilient, and we have to give that chance for everyone who is not really an excellent performer or is not a professional operator to participate in securing the Ethereum network. Because if we want to decentralize the network and to democratize the Ethereum network, we have to give it access to everyone. The biggest issue that we are facing, and it's something that has been mentioned in the previous talk as well, is how do you estimate the penalties that are going to be imposed on each one of the participants in the network. When you are distributing all the nodes, one of the issues that you have is that you have multiple actors, you have to track performance, you have to assign individual penalties, and that is extremely, extremely complex. And just kind of to sum up, because at the end of the day, that was kind of the main goal of the talk is, okay, we have explained what is DVT, we have explained how it's being implemented on validating in Ethereum, but how does it match with reestaking and what does it bring to the table when talking about reestaking? And the truth is that when we are matching DVT with reestaking, we are creating a way more secure environment there where it's needed the most. Because at the end of the day, one of the biggest risks, and coming back to one of the first slides, one of the biggest risks with reestaking is that you are using Ethereum security for all the things. So you truly need to secure or to give a more resilient way to do that. Otherwise, you are going to create a cascade effect that is going to affect us, all of us, everybody who is building on Ethereum. I think I've done the presentation way too fast, so I'm going to have a lot of time for questions, but actually it's pretty much up to here. Thank you very much, everyone. If you want to reach out to me, just do that. I'm in Telegram, Discord, whatever you want. Thank you very much.
Thank you, Raul. Any questions? Yeah, please.
Thank you for the talk. Maybe like a simple question, I'm not that deeply familiar, but in DVT, when we share the key, is the key recombined at some point at some node, or are nodes exchanging signatures that they like sign gradually?
One node is not the owner of the key itself, is what you mean. I mean, at the end of the day, it's recombined, but it's recombined by the soul set. They have signed and it's recombined, but at the protocol level. It's not that it's owned by one node and it's pushing. It's like there is a cluster.
I'm just curious, like, how is this data exchange coordinated? Because if we're like 3 nodes, that one node must sign first and then transfer this half-signed transaction, if you will, to another node. So who does this coordination? How do they send this to each other?
Actually, there are different implementations depending on the protocol. I think Raul and SSB, they have their own way to do that. I think, maybe I'm mistaken, but I think Raul, they do appoint one leader within the subset. In our case, it's a random system. We have designed our own sort of consensus mechanism, which actually appoints randomly one node within the subsets.
Any other questions? Thank you for the
Thank you very
participating.
much.
Thank you.